We are recording. So, let us start with some opening exercises. So, I want you to consider exercise 1, or exercise alpha, I guess, and talk amongst your neighbors about how these two equations are related. How is this one related to this one? So I'll give you guys 2 minutes to talk amongst yourselves. Bailey, go ahead and turn around and talk to Abby. Abby's got an exciting weekend of things and stuff that she's doing. Ain't that right, Abby? Talk to each other. Wait until we have the class. We're not getting started here. All right. Okie dokie. What do these two guys have in common? They have the same expression, right? But they don't look the same, do they, Trey? Not really. But they got all the same stuff, don't they? They got all the same stuff. So how can I say that they're the same expression? Let me ask this a different way, and I asked a few of your tables as I was walking around. What do I have to do to this guy to make it look exactly like this guy? And before you answer, we are in algebra class, so we're going to use algebra terms. We're not just going to say, what did we say? Make a move? We're not going to say make a move. We're going to use our algebra terms. So what do I have to do to this equation? Bailey, you wanted to participate?
I don't know for myself.
That's okay.
But it's okay, so, yeah, I don't know.
It was right there. It was right there. I should have sprung the trap when you were eating the treat in the snare, right? All right. So what do I do to the equation on the left to make it look like the equation on the right? I got a fraction over here, right? Over here I have no fraction. Let me ask this, how do I get rid of the fraction on the left-hand side? Right? I'm dividing already, right? I'm dividing. A fraction is just a fancy way of dividing, right?
Yeah.
So what's the opposite of dividing?
Multiply.
What am I going to multiply by?
X minus 1. No.
Let me ask you this. Let me ask everybody this. If I said, no, I don't want to write it like that. I want to do 1 equals 1/2. How do you get rid of the denominator in that one? How do you get rid of the denominator in 1/2? Say that again, Michaela, nice and loud so everybody can hear. You multiply by 2. If I multiply this by 2, then I have to do what to this side? Multiply by 2. And what happens? Well, this becomes 2, because I know what 2 times 1 is. But what happens here? I multiply 2 by 1/2. Well, 2 times 1/2 is simply 1. Right? So, I multiplied by the denominator to get rid of the denominator. What do I multiply by here? Okay.
Multiply?
Yeah, I gave you that. Multiply by what? 2. Well, we're done with that. We're done with that. That was like 3 minutes ago. We're down here now. We're back down here again.
Down there, or multiply by x plus 1.
X plus 1. If I multiply this side by, oh my goodness, x plus 1. And if I multiply this side by x plus 1, what do I have to do to the other side? What do you think there, Allison? I multiply by this side of the equation by x plus 1. What do I have to do to the other side? The same thing, that's right. So then this is going to be times x plus 1 as well. What happens over here is denominator gets canceled out, and I'm left with x squared minus 1. And over here, I'm left with x minus 1 times x plus 1. So do you see how I made the one side look, or the one equation look just like the other? We are going to be able to find those patterns and make our lives so much easier. Okay, so I want you to explain, and again, a couple minutes, explain the relationship between the polynomial identities, this polynomial identity right here. What do we call this, ladies and gentlemen? Nice and loud for everybody. It's on your sheet if you can't read back that far. What do we call that identity? Starts with a D, ends in difference of difference of squares. This guy is difference of squares, right? When I see that, I know this is a square term. X squared is just taking x and squaring it. And 1, well, that's just 1 times 1, right? So that's also a square term. I can factor it like this. I want you to compare that relationship with this relationship. Hi, Giselle. There's a packet right there on the chair for you. Here, let me grab it for you. You have this much. We are at letter D. What do you think A is in this identity? I got Mason knows, but I'm going to hold off on calling him. What do you think the A value is in that identity that I underlined, Jordan? Close. Not -1, but 1, right? A is 1. Okay. Good. So A equals 1 and x squared minus 1 equals x plus 1 times x plus 1. 5. I got something for you. Okay. And we just finished letter B. All right. Now, here's what I want to do. I want to go over exercise 1 together. I want to go over exercise 1A together so that you guys know what to do in letters B. And is there a C over here? C and D. Okay? So, for letter A, it says, compute the following products using the difference of squares identity. Okay? So, it says 6 times 8. And we all know in our heads what 6 times 8 is, right? Right. You know what 6 times 8 is, right? Not top of your head? 48, right? 48. Use the calculator if we don't know, right? You got your calculator with you? In your locker? Always bring your calculator to math class, okay? I might ask you to put it away, in which case, no harm, no foul. But bring it so that when I tell you to take it out, you got it, right? All right, so I know what 6 times 8 is, but it's saying compute this using difference of squares. Luckily, they gave me a really easy one because 6 and 8 are really close together. As a matter of fact, there's only one number that's in between those two, right? What number is in between 6 and 8? 7. Say 17. There you go. So 7 is in between 6 and 8. So how does this factor? Well, this is the same, 6 times 8 is the same thing as saying 7 minus 1. Does that equal 6? Last I checked, right? And then, what do you think I put over here? 7 plus 1, right? Because this is my identity right here. Okay? So this is the same as saying this, which is also the same as saying, oh, 7 squared, finish the pattern. If this equals this, what does this equal? Where's the pattern? What do I do to finish this out? What do you think, Abby? 7 squared equals 49, but that's not what I'm asking right now. I'm asking you to finish this pattern right here. There you go, John. Minus 1 squared. There's my pattern. There's my pattern. Okay? Now, I want you to simplify 7 squared minus 1 squared. 7 squared is, what did you say again?
49.
49, thank you. Minus, what's 1 squared? 1, which equals 48. Common Core math at its very finest, right? This is what you see on the Facebook, and I say, why are they making us do this? Why are they making us do this? How many people are going to do that on their homework this weekend? Okay? Now, why do we make you do this?
So that we can get better at mathematics.
I want you, that's a good stock answer, right? It works for just about everything as to why Mr. Cook makes you do this in math class. But specifically, I want you to understand and be able to see patterns in things. Okay? We're looking for underlying patterns that are always true. That's what an identity is. An identity is a pattern that is always true no matter what. Okay? And we have a pattern here. So what we want to do is when we see it in life, we want to be able to use the patterns that we know to recreate and make our lives easier. Are you going to multiply using difference of squares in life? What do you think, Alvin? No, you're not. You're right. No, you're not. However, comma. Will you use patterns to fix problems in your life? Are you kidding me? You're not going to use patterns. Hey, when I hit my head against the wall, my head hurts. That's a pattern, right? Isn't that a pattern? When I get my ankles broken in basketball, I gotta walk around in crutches for 8 weeks. That's a pattern, right? Oh. Hey, I'm just dogging you. Come on, sit back down. Don't get blood hurt. Don't get blood hurt. Come on. Did that just happen? I know he'll be back. He's playing it out. I just can't play games with him, that's all. It's just going to have to be business between us. All right. So, that's why we do this, though. You got it? So, I want you guys to do B, C, and D on the next page. I know, you got stepped on. I'm just using that. I stepped on the red's foot and broke my shins. That was pretty funny, though. That's not funny. That was hilarious. And you took it, and you went with it, and I kept playing. You kept playing, I know. I know. Now, hey, we're doing B, C, and D on our own. I'll give you till, I think till the 10, till the minute here on the 10. I'm sorry? Now, how do I do for letter B? What numbers are between 11 and 19? And think of a number, you're on it, right? Think of a number that when I add it to that number, I get 19, and I subtract it from that number, I get 11. Right? So I'm looking for two numbers that will add to 19 and subtract to get 11. This is not what I want. Oh yeah, we're almost done. My only possibility. There you go. How we doing, Craig? Okay. So, you know what I like to do when I'm with problems like this? Is I think about it. So, 12 is between 11 and 19, right? What number do I have to subtract 1. Now, when I add 1 to 12, I get 19. So throw 12 out. Now we need 13. What do I have to subtract from 13 to get 11? Okay, when I add 2 to 13, I get 19. Throw it out. What's my next number? Pick a number. Subtract from 13 to get 11. And then I add 4 to 13 and I get what? So that's a big one, right? So now, we know 15, that's that last one, right? What did I have to subtract from 15 to get 11? Yeah, you can. Did you go to the bathroom when you stomped out? All butthurt and stuff? Did you do that? Okay. That was fun. That was fun. I had fun, Brandon. All right. right, don't forget C and D on the next slide. Don't forget C and D. Yeah, how's ABC look? All right, I'm gonna look at that. When you get back, we'll talk, okay? How we doing there? He's on that calculator right now. Unnecessarily long with the approach, right? Well, let's just go. All right, beautiful, beautiful. So, Giselle, wait, who stole my stylus? Who's got my stylus?
You have the stylus.
Where?
I'll figure it out. The pattern.
Where's my stylus? Oh, man, because I have so much fun this year. All right, what are my two numbers? What are my two numbers for letter B? 15 and 4. So this equals 15 minus 4 times 15 plus 4, which equals what? Very good. And that yields me 225 minus 16, which is, what is that? That is 209? Is that what I get when I punch in 11 times 9? That's 190 plus 11? No. Did I do that right? 190? No, 190 plus 19, which is 209. Yep. Okay. Now, 2317. Thank you, Pam. Equals 20 plus 3 times 20 minus 3. And if I simplify that, into our difference of squares pattern. Brandon?
What?
What's my next line?
20 squared minus 6 squared.
20 squared minus 3 squared. And if I simplify that down, I get 391. And that box that stuff, because that's my answer. Now, 34 minus 26. Kyle, what were your numbers here? 30 minus 4 and 4 times 30 plus 4. Which equals what? 30 squared minus 4 squared. That's how you can multiply big numbers in your head. No fooling. No fooling. Which is 84. Is that what we get? 84? All right. Now, we are going to go the other way. We're going to go the other way. Is this a square term? 2 to the 100th power. Who says 2 to the 100th is a perfect square term? I say it is. Right? What is the square root of 2 to the 100th power?
400.
I'm sorry? 2 to what power?
2 to the 25.
What? I'm so
2 to the 50th. Because when I multiply 2 to the 50th times 2 to the 50th, when I multiply those, what do I do to the exponents? You add them, right? If I do this, what do I do? You multiply. Power to a power, I multiply. Power times a power, I add. As long as the bases are the same, yes? Okay. So the square root of 2 to the 100th is 2 to the 50th. So, how do I factor this? This is 2 to the 50th minus 1. 2 to the 50th plus 1. Well, let's check. Let's check. Ooh. Now, I ask you, is this a perfectly square term? Yeah, it is. Could I factor this one further? What's the square root of 2 to the 50th? 2 to the 25th. Oops. I did a boo-boo. But I do math in pencil so I can erase. 2 to the 25th minus 1 times plus 1. And then times, can I factor this at all? Is this one of my 3 approved patterns? Not quite. Right not. No, Poppy. This is not one of my patterns. Now, if this was to the 150th power, that would be sum of cubes, which is one of my things, but it's not that. So I can't factor that any further. So this just stays 2 to the 50th plus 1. Now I found 3 factors. Can I factor this any further? Can I factor this any further? What do you think? What do you think, Mason? Is sum of squares something that I have the pattern for? No. I got difference of squares, but I don't have sum of squares. Do I have sum of cubes as a pattern? Yeah. So if it was a cube, I could do it, but it's not a cube, is it? Okay? Now, this one's fun. This one's fun. Show that 18 cubed minus 1 is divisible by 7. What is this pattern called? What's that pattern called, Jordan? I got, what's that thing called? Cube, right? And what's that thing called? Minus, but I also call it the, starts with a D, ends in difference. Oh, not difference of squares, difference of cubes. All right, refer back to your notes from yesterday. What is the pattern for difference of cubes? I'm sorry. If you have x cubed minus a cubed, that equals what? X minus a times x squared plus xa plus a squared. Check your notes from yesterday. Is that the right pattern? XA. Is that the right pattern? Did I do that correctly, Ty? Mason, have you checked your notes from yesterday? Did I do that right? I did it right? Okay. All right, so apply this pattern. Yeah, my A's are looking like 9s there, aren't they? Let me fix that. Okay. Is that better? Better yet. Better yet. How's that? Guys. I do my Z's like this. I do my Z's like that. No making you guys happy. Okay, so apply the pattern. So what is one? So this is my x in this is what? What is my x in this term right here? It's 8, right? And my a term is 1. And 1 cubed is the same as 1, so I'm going to put a cubed right there. Now, wherever I see an x in my pattern, I put a what? Sydney? When I see an x in my pattern, I put a what? An 8, that's right. So I got 8 minus 1 here. And then over here, I got what? 8 squared plus 8 times what? 8 times 1 plus 1 squared. Bam! And what is 8 minus 1? 7. Oh, goody! I've just shown that. Well, let's finish this. 7 times what? What's 8 squared?
64.
Yes, sir. Plus 8 plus 1. So that is 7 times 24 plus 8, 72 plus 1, 73. Now, here's what I want. Who's got calculators here? All right, Cam, do 8 cubed minus 1. John, do 7 times 73. No, do 7 cubed. Do 7 times 73. What'd you get, Cam? I'm sorry, I can't hear you. When you say it's 8 cubed minus 1, you got what? Yeah. There you go. Alright. So, here's what Cam did. Very, very well thought out. Cam did 8 cubed minus 1, and you got 511, did you say? That equals 511 on Cam's calculator. And then he did this. He divided 511 by 7. And guess what he got? 73. Bam, mic drop. Alright, good. So, we are done with lesson 7. Problem set. Due on Monday. 1 through 4, 6, and 7. Due on Monday. How do I like my problem sets turned in? Separate sheet of paper. I still have no names on top of lesson 4s in my basket here. So when you turn in lesson 7, please be sure to put your name on it. If you have lesson 6 done, please turn it into the top center unless you're in Mr. Erickson's class. And then turn it into him after 10 after. Bam. Like right after? I tell you what, if you're in class, do not interrupt, okay? So when you're done, come right back, please. So we are doing one, all over, 2, 3, 4, both of them.